We're going to use a technique of integration called the method of partial fraction to integrate 2x squared minus x plus 4 divided by x cubed plus 4x. First, we have to make sure we can use this method directly by checking that the degree of the numerator is strictly less than the degree of the denominator. Well, in this case, the degree of the numerator, it's a second degree polynomial, it's 2. It's less than the degree of the denominator, which is a third degree polynomial. So the answer is yes, and we can proceed. Next, we take 2x squared minus x plus 4 divided by x cubed plus 4x and see if we can factor the denominator. Since the denominator is third degree polynomial, third degree polynomials can always be factored, and in this case it factors into x times x squared plus 4. Now notice that x squared plus 4 cannot be factored further. It's called an irreducible quadratic polynomial because we cannot write it as a product of two linear terms. So partial fraction decomposition looks like this. We have x, which is a linear term. We put a constant a above it. And then we have an irreducible quadratic term, x squared plus 4, and we must put a possible linear term above it. It has to look like this, bx plus c. It's very important that you always put above any power of irreducible quadratic polynomial a linear term like bx plus c or cx plus d or dx plus e, depending on which of the letters have already been used. Now let's multiply both sides by the denominator from the left, and that is going to give us, on the left we have 2x squared minus x plus 4, and on the right after cancellation a times x squared plus 4 plus bx plus c times x. Let's plug in 0 for x. The left hand side we have 4. On the right, the bx plus c part will be 0 since it's multiplied by x. We have 4a, and that's easy enough. A must be 1. To solve for b and c, we could plug in two other constants if we wanted to, but it's probably easier to do the following. We have 2x squared minus x plus 4 on the left. A is already 1, so that gives us x squared plus 4 plus bx squared plus cx. So the 4's cancel, and that gives us 2x squared minus x on the left. Here's x squared plus bx squared, that's b plus 1, x squared plus cx. Now these are equal, so the coefficients of x squared and x must be equal. On the left, the coefficient of x squared is 2. On the right is b plus 1. That gives us b equal 1. And on the left, coefficient of x is minus 1. On the right, that's c. C must be minus 1. We solve for a, for b, and for c. Then our integral, 2x squared minus x plus 4 divided by x cubed plus 4x is the same as that of 2x squared minus x plus 4 divided by x times x squared plus 4. And that's equal to a, the integral of a over x, so that's 1 over x, plus the integral of bx plus c, so that's x minus 1, divided by x squared plus 4 dx. And let's write it as 3 integrals, and these integrals are integral of 1 over x plus the integral of x divided by x squared plus 4 minus the integral of 1 divided by x squared plus 4. So these 3 integrals should be much easier than the original integral, so that's why we use this method of partial fraction. Clearly the first integral is natural log of absolute value of x. For the second integral we use the u substitution. U equals x squared plus 4, so the du is 2x dx, and 1/2 du equals to x dx. The integral then becomes x dx is 1/2 du. We have u in the denominator. That's 1/2 times the natural log of absolute value of u. Since u is x squared plus 4, it's never negative and never 0. This is 1/2 natural log without absolute value, x squared plus 4. So let's summarize what we have so far. So far we have natural log of absolute value of x plus 1/2 times a natural log of x squared plus 4. That's already done. And now we have to do is finish one more integral. It's 1 divided by x squared plus 4. Now you can use the formula to integrate 1 over x squared plus 4 if you remember how to do that. If not, make the following substitution. Let x be 2 times tangent of theta, so that x squared is equal to 4 times tangent squared theta, and x squared plus 4 is equal to 4 times tangent squared theta plus 4. Of course, we know that we can factor out 4. This is equal to 4 times tangent squared theta plus 1, and using trig identity, that is 4 times secant squared of theta. And then from this x, of course, dx is equal to 2 times secant squared theta d theta. So returning to the integral, the numerator is dx, 2 secant squared theta d theta. The denominator is x squared plus 4, that's 4 secant squared of theta. Secant squares cancel, and we have the integral of 1/2 times 1 d theta, which is 1/2 times theta. Well, we have to solve for x. The definition was x equal to 2 times tangent theta. That means x over 2 is tangent theta, and therefore theta is equal to inverse tangent of x divided by 2. Let's put it all together and write the final answer to the problem. The integral of 2x squared minus x plus 4 divided by x cubed plus 4x is now solved. It is equal to natural log of absolute value of x plus 1/2 times the natural log of x squared plus 4 minus 1/2 times inverse tangent of x over 2, and now we can add constant of integration at the end. So the new thing here that we did not do in earlier videos was how do you handle an irreducible quadratic polynomial, and I hope you see how to do that. It's not much harder than handling linear terms. For more videos